We're introducing some new notation that is going to be a shorthand for combining functions in different ways. So if we have two functions, f and g, and we want to add these two functions together, we're going to say that there's a shorthand available to us. So f of x plus g of x, if we were to add that together, it's shorter to just write f plus g of x like this. Or even shorter to just say f plus g and drop the of x notation. If we want to just refer to it by name, we might just call it f plus g or the f plus g function. If we actually need to algebraically plug values in, it might be better to use the f plus g of x notation so that we have a spot for seeing who the independent variable is that is to be plugged in. Similarly, if we are looking to subtract the two functions, f of x minus g of x, it's shorter to just write f minus g of x, but even shorter to just say the f minus g function. So if I'm calling it by name, I might just call it the f minus g function. If I want to multiply two functions together, the shorthand that we use is f times g, or even just f dot g of x, or we could say that f times g of x function is simply going to be referred to as the f times g function like this. The f divided by g function is what we would use if we were going to take the f of x function, divide it by the g of x function. The shorthand notation for that is just f divided by g of x. And again, similarly, we could also call the f of x divided by g of x function just f divided by g. So let's take a look at a quick example to see how these shorthands can work in our favor. So we see that we have an f function that is rad x and a g function that is x value minus 5, and we want to find the f plus g function. Well, we know that this notation, f plus g of x, is shorthand for the f of x function plus the g of x function. So the f plus g function, and actually in this line, I'm going to drop the of x bit to have an even shorter shorthand. But still, f plus g is going to be determined by taking the f function, which is square root x, and adding the g function to it. And the g function is x minus 5. Now, we are done. We're not trying to solve for x here. Remember, we only solve for x if we have a one variable equation. This is not a one variable equation where we would solve for x. This is two variables. This f plus g is actually taking the place of y. So this is the same thing as y is equal to rad x plus x minus 5. And that's something that's going to have a graph. It's not going to be something that we solve for x. So now we would say, okay, I have the f plus g function because we just found that quantity. What is the value of f plus g at 4? So let's remember what this notation is actually telling us. This notation means to go to the f plus g function, plug in the x value 4, and then determine the output or the corresponding y value. And that notation is the shorthand for all of this language. So we'll say, in order to find f plus g evaluated at 4, we need to locate the f plus g function. Well, here's the f plus g function. So to find f plus g evaluated at 4, I'm going to take this function and plug in x is equal to 4 to it. Remember, this value here is indicating the x value that I'm going to plug into the f plus g function. So let's do it. We have the square root of, since I'm going to be plugging something in for x, I'm going to first open up an x spot. So we'll say rad x plus x minus 5, and the value that we need to be plugging in for the x is 4. So the f plus g function evaluated at 4 is going to be 2 plus 4 minus 5, which is going to be positive 1. The f plus g function evaluated at 4 is positive 1. Now, Let's find out what f plus g function evaluated at -2 is. Remember, the f plus g function that we found already, and let's say this time just copying down f plus g of x. This is the generic function that has the x's still in it. So this was rad x plus x minus 5. We got this function by adding the f function and adding the g function together. So to find f plus g evaluated at -2, we would simply take the -2 and replace that x with -2 in the function. So we'll open up our x holes. We're going to plug in -2 right here, and here we actually have a problem. Now we have -2 that is going to be under a radical, which is going to indicate that we're going to have an imaginary output. Any x value that would cause an imaginary output is not going to be an element of the domain. So we would say x is equal to -2 is not in the domain of the f plus g function.